We'll get started here in about 5 minutes. Thanks for your patience. We'll get started in about 2 minutes. Thanks for your patience. All right, everybody. Thanks for joining in this morning. I'm going to go ahead and share my screen. As a reminder, this session is being recorded. I will provide access to the recording after the class is done once I get it captioned. I do apologize that I've not posted Tuesday's video. There are several videos that were created for Tuesday's class because anytime someone joins the class early, it starts a recording. So what I have to then do is go back and sift through all the different recordings that were created to see which one is actually the class session that I created. So apologies, but there are about 10 different ones out there, and I just haven't had a moment to go through all of them to make sure of which one is the actual recording. And as soon as I figure that out, I'll get it captioned and get it posted. I hope to get that done for you today. So you'll have access to Tuesday's class and today's class. All right. So before I move forward, I want to open the floor and ask, are there any pressing questions that I can answer about anything before we jump into today's material? Any questions about anything that's related to the class or your assignments or anything?
No, ma'am.
Thank you. Oh, I'm sorry, my audio was, I'm sure, was very low. Apologies. Hopefully you heard me okay. Let me just ask, is everyone seeing the course homepage right now?
Yes, ma'am.
Thank you very much. I'm going to try to, be as loud as I can because it is storming here at my house right now, literally. So the rain is like really coming down heavy. Hopefully we don't have any connectivity issues, but in the event we do, I will make you aware of how we'll proceed. Okay. So on Tuesday, if my memory serves me correct, we had started talking about unit conversions. And I had actually gone through my supplemental notes that are listed here and gave you some background on conversion factors, and including what is a conversion factor, where you find them. I showed you a couple of resources here in the class where you can find a chart that'll help you do unit conversions. And of course, there are conversion charts throughout my notes. And I mentioned that, anytime you're having to do a unit conversion on any type of assignment, even an exam, you are most welcome to have a printed copy of a conversion chart of your choice. And if, that's not, we'll put it this way, if there's something outside of that you need, I will make sure that you have access to it. Let's just leave it at that, right? Because, I've been telling you all along, I don't want you memorizing things. I want you to use the resources, because sometimes it's not so important that you know everything, but the important thing is, do you know where to find what you need, right? So I ended by looking at a few unit conversions that were in the supplemental notes, but I told you today what I wanted to do was I wanted to tackle some examples that you might be, that you created, right? Your task was to come up with a unit conversion question, solve it, and then we were going to talk about your solution to see if you're on the right track. Again, let me just say this is not a punitive kind of thing at all. It is really for the benefit of everybody, the sharing that I hope will take place. And then once we've looked at a couple of examples that you guys want to share, then I'm going to go in and share some additional examples from my extra notes so that you see directly where you can find some other examples of unit conversions, all right? So what I'm going to do now is I'm going to stop my share, and I'm going to ask if there's anybody who wants to share their screen, because wait, no, I was just looking at the settings. Okay, so I've put the settings on to where anybody who wants to share their example with me can do so. Just for the benefit of keeping this orderly, if you're going to share, let me know so that somebody else doesn't jump, doesn't also try to share with you simultaneously. So is there anyone who wants to share their sample unit conversion problem? Nobody? I'm sure there's somebody that's brave enough who has tried at least one and wants to share it. Okay, well, okay, so I will close the sharing out. Oh, I see Oren connecting to audio. Did you have a question, Oren? So what we're doing right now is you are tasked on Tuesday to come up with an example of a unit conversion problem and share it. And so we could all discuss it. And I just set the sharing permission so that anybody who wants to do that can do that. Oren, if you were unmuting because you wanted to share, please let me know because you have access to sharing your screen.
No, ma'am, that was by accident.
Okay, no problem. All right, so what I'm gonna do now is I'm gonna close out the permission. So now only I said it so that only I can share right now. And I will in just a moment. But let me just, I don't know, up the ante a little bit. I didn't say this up front. Maybe I should have. But if you had taken me up on sharing your example with the class, it was worth 5 bonus points. So that window is not closed. So maybe that'll be an incentive so that next time I ask for you to, be willing to share, you'll be thinking in the back of your mind, I'm sure this is worth bonus points. Okay. So I don't always announce ahead of time bonus points, but I do give them sometimes rather randomly, but as an incentive to get to encourage you to be engaged during this whole process. Okay. Because as I told you before, I can talk till I'm blue in the face, but especially with a topic like unit conversions, until you actually do them, sometimes you figure out what you don't know in the trying, right? Measurement is that kind of activity. Yes, some of you have been doing this all along, and maybe that's the case, and that maybe that's why you didn't want to share, because you're like, I already know this. But I guarantee you, and it always shows up come exam time, folk really don't know how to do unit conversions. And it doesn't come up until you actually do it in an assignment. And so I was trying to, create an opportunity for you to do that where there's no penalty involved at all, right? So since I didn't get any takers on that, I guess it's up to me to do all of the sharing. And, I brought you to the announcements Tuesday and kind of reminded you of many of the resources that you have available. And one of them is the extra resources. And so if you click on extra resources, you see this link comes up and it takes you out to folders related to the topics that we cover. So these are just some additional resources that you have access to support this class. If you don't use them, you aren't missing anything, because I cover the content and the concepts in my supplemental notes. These are just some really cool examples of the topics that we cover. but I don't put them in my class because I have to use them with the understanding that there's certain guidelines that they don't necessarily meet, but they're really good for what we are doing. And so that's why they're in the announcements instead of in the course material. So this first slide here talks about, it shows two different types of techniques that you can use to do unit conversions. The first one, the SI prefix conversion method, is for converting within the metric system. So for example, if you wanted to convert milliliters to liters, or megameters to picometers, so within the metric system. And of course, you have to understand the concept to do that SI prefix conversion method, that you can only convert within the same property, meaning you can convert a length metric measurement to another equivalent metric length measurement, but you can't convert a metric length measurement to a metric volume measurement, okay? So it has to be the same property when you do these metric conversions, length to length, mass to mass, so on, right? Now, we'll look at an example or two of this method, but I don't spend too much time on it because it's limited. It's only for metric conversion. What I really want to do is work examples that relate to the dimensional analysis technique, because that technique is most inclusive, meaning you can do any types of conversions using a dimensional analysis technique. And that's the technique that I focused on in my supplemental notes on Tuesday, when we did, the few examples that are listed there. And so I'll do way more examples of that than the metric prefix conversion. Now you can definitely use this technique if you're doing metric conversions. And so that's why I put it in, that's why I just briefly go over it. So when you do a metric conversion, or a prefix conversion, and they call it prefix because it's really based on the prefix in the power of 10. If you recall, every metric prefixes have associated powers of 10 exponents, right? And so when you're doing a metric conversion, what you're doing is moving the decimal place according to the difference between those two exponents, okay? Now, a lot of times students get that concept, and some of you may even have a chart that you were given at some point in your academic preparation, where you see how to convert from one metric unit to another, because it shows you the prefixes and the powers of 10, and you just count on that chart. But a lot of times what confuses students when they're doing metric conversions is that they don't know which direction to move the decimal place. They can figure out how many places, but they don't know do I move that many places left or right? And so what I have in here is a really cool chart. And you might recall seeing this prefix chart before, because we talked about it last week when I introduced the metric prefixes and powers of 10. Because remember, the whole point of this chart is that you can use it to make fractions of or multiples of your base. And I like this chart because it's more condensed, right? It has the prefixes that we'll most often use. But the other cool thing is that if you look on the left side, it tells you where, do you move the decimal point to the left or right? So for example, if your exponent is getting more positive, so if you're converting from micrometers to kilometers, your exponent is getting more positive. So you have to move the decimal point to the left, okay? And in the example I gave, micrometers to I don't remember the example, but let's say, for example, you're going from nanometers to decimeters. Okay, so your exponent is getting more positive. And the question is, how many places do you have to move it? Well, if you start off at -9 and you end up at -1, you have to move the decimal point 8 places to the left. Okay. For example, if your exponent is getting more negative, then you move your decimal point to the right. So if you're converting from kilometers to millimeters, then you're going to move your decimal point to the right because your exponent is getting more negative. Okay. And in that case, you're starting at +3 and ending at -3. So that's a total of 6 places. Okay. So this chart is a really cool tool to use if you're just doing metric conversions based on the prefix and power of 10. You just have to find the difference between the exponents and then move your decimal point to the left or right. Let me caution you though, when you find a difference, that difference is not going to be negative because in essence, it's just asking you how many steps would you take, and you can't take negative steps if you want to think of it that way. Okay, so they have a couple of examples here. So the first one is like they're doing 532 meters and they want to know how many kilometers. Well, if you're going from, your base meters to kilometers, which has a prefix of 10 to the 3, because that's what kilo represents, then you have to move your decimal point 3 places. Now, the trick here is, well, what power of 10 goes with the 532? Because you don't see a prefix there. Anytime you don't see a prefix, the power of 10 is 0. So you're starting from 0 and you're going to +3 because that's what kilo represents. And so, if you're moving in a direction where your exponent is getting more positive, because 0 falls right in here, right? -1, 0, right? Then you have to move your decimal point 3 places to the left. And that's exactly what they did. They took this example where the decimal point is behind a 2 and moved it 3 places to the left. 1, 2, 3. So 532 meters is equal to 0.532 kilometers. Okay, that's an example of a metric conversion using the SI prefix conversion technique. So these are some examples with the answers provided. And what I want to do right now is just take maybe a 5-minute break, and you pick one of them and work it and see if you understand why they got the answer that they did. And then in 5 minutes, if you have a question, if you didn't know how to do the one you picked, then let's talk about it. Okay. So I'm going to leave the sharing on, but I'm going to stop my video and I'm going to mute my mic for 5 minutes. So we'll come back at, let's say 10:25 to make it even, right? And then we'll talk about your example if it didn't make sense to you. All right, everybody, welcome back. So let's talk about these 4 examples. Is there anybody who tried one of these but didn't understand the answer? In other words, you couldn't figure out how to get the answer that's given. All right, so that means everybody in here is a SI prefix or metric prefix conversion expert. That's good to know. I'm glad that it made sense to you. Maybe something I said helped, or maybe you already knew how to do it. So either way, that's a good thing. All right.
Question.
Yes.
I know how to get my answer. However, I don't know how to do like the breakdown where you show your work.
Okay. Oh, okay. I got you. So you know how to do metric conversions, but it's a question of what do I want to see? What would I consider showing your work? Is that what you're asking me?
Yes, ma'am.
So in this case, for example, let's say the number 1, 20 centimeters, and they want to know how many meters. So obviously in this particular case, they move the decimal point 2 places, right? And they move the decimal point 2 places to the left. So if you just wrote 2 left, or sometimes how you take, you draw the little loops to show how many places you move the decimal point, just something, put 2L and that, that'll be fine if you're using this technique, or just show the little, loops to show I move the decimal point from behind the 0 to in front of the 2. If you're using the technique that I'm about to discuss, then it'll be readily evident how to show your work. But with this one, I'm not asking you to like show me a whole bunch of stuff, just something to let me know you knew which direction to move the decimal point and how many places to move it. Is that okay?
Yes, ma'am.
Okay, great. And anybody else out, if that was a question that you needed answered but didn't think of it, there you go. Okay. Now, the other method we're going to look at is the dimensional analysis technique. And I prefer this technique because I can do any kind of unit conversion with this technique. I can do metric conversions. I can do English conversions. I can do metric to English or English to metric. I can do any type of conversion as long as I have a conversion factor. And we talked about on Tuesday that a conversion factor is just a fancy way of writing 1 that allows you to cancel out like units that you have and keep the unit that you want. Okay, so you have to be comfortable with the idea that to use the dimensional analysis technique, you're going to be canceling out like units. All right, and these are basically the steps that you go through. Again, if you're working the problem, I don't expect you to, step 1, step 2. You just do it, show the work, right? But if you had to go through a thought process of what is it that I actually do when I do a unit conversion, this is what you actually do in order to do a unit conversion. So, I like step number 1 because it makes me pause for a moment and think about, okay, what unit am I starting out with and what unit do I want to end up with? Okay. I have, yes, somebody else have a question.
Yes. Are you going to put these notes are going to be on?
All these notes are on Canvas already. Again, I pulled this out of the announcements.
Okay. All right.
That extra note, extra resources link in the announcements will take you to this folder where you find this item.
That's only if you have access to Google Drive, correct?
You don't have to have access to Google Drive. If you click on it, I'm giving you access to my Google Drive.
Okay.
So have you tried clicking on any of them?
I went to go on the link that you provided, and it's asking me to log into my Google Drive.
That shouldn't happen. I'm gonna go back and and put the link again after, I'll do it after we finish. Because it might be doing that behind some type of security permission thing. And let me work on that. And if it turns out that, you know, they're giving me grief on that, what I'll do is make the folders available to you right on Canvas. Okay.
Okay, thank you.
Apologies, I did not realize that because nobody told me. I mean, since the account is mine, it doesn't ever block me from going into it.
Yeah, just access for access, and then I tried doing it. It says access denied.
Okay, usually if you, I think I know what's going on there. Some students, when they click on that, they just choose the option request access, and then I grant them access because I see those emails popping up, but I didn't know what was going on there.
Okay, sounds good. Thank you.
Yeah, no problem. All right, so thank you for bringing that up because yeah, Google's been kind of going through its privacy things, I guess, and changing things. So I'll fix that, and then we'll have to talk when we meet on Tuesday to make sure that that once I make the adjustment, you can still get in it. Okay, so I'll do that on just after we're done. All right, so back to the example here on dimensional analysis. So as I was saying, step number one, I always like to pause for a moment before I start working the problem and ask myself, what unit do I have? What unit am I starting with? And what unit do I want to end up with? Okay. And then, of course, I have to use the appropriate conversion factor that will help me to convert from the unit I have to the unit I want. And remember, the important thing there is that you line up the conversion factor properly so you cancel out the unit you have and keep the unit you want. Okay, and we'll see that in the examples that I'm going to go through. And then, of course, multiply all your top numbers, multiply all your bottom numbers, and then divide. I do it that way because that is the easiest way to avoid mistakes. Okay, and then, of course, anytime you're working any kind of problem, go back and check your units to make sure you did in fact cancel properly and you got the unit you wanted in the answer, and check your numbers. Okay. All right. So the whole business about lining up your conversion factor here is a good way to think about this. So if you recall in the notes on Tuesday, one of the conversion factors in the conversion chart was 1 inch equals, they have 2.2 centimeters, but I use 2.54 because I like the 2 decimal places, right? They kind of round it a bit more than I would have. But if you use their conversion factor, I wouldn't penalize you as long as you worked it correctly, right? But here's an example of a conversion factor. 1 inch is equal to 2.54 centimeters. And you know that if you divide two things that are equal, you get 1. So since 1 inch is equal to 2.54 centimeters, you're dividing by itself, right? Anything divided by itself is 1. But notice in this first one, how the conversion factor is lined up. It's lined up with the inches on the top and the centimeters on the bottom. That means that you're converting from centimeters to inches. Okay, in this particular, arrangement or lining up of the conversion factor. In the bottom, you're still dividing, two things that are equivalent and getting 1, but notice how it's lined up. It's lined up with the centimeters in the top and the inches in the bottom. So it means that you're converting from inches to centimeters if it's lined up that way, okay? And in this course, I'll just let you know up front, I'm not trying to get all exotic where, like you're dividing by the conversion factor. We'll try to keep the examples that you'll have to deal with straightforward enough to where the unit that's on the bottom is the one that's being canceled out. And the one on the top is the one that's being kept. Okay. Any questions about that?
No, ma'am.
And you know, I just thought of something, you know, I'm using these extra notes is being recorded. So everything that I'm doing with the extra notes is being recorded. So if you looked at the recording, you would see everything that's in the extra notes, even if you couldn't get into the Google Drive folder. But I'm still going to make sure you have access with it, you know. But, you know, that just popped in my head. Hey, this is being recorded. So they can definitely go back and always review the recording to get, you know, a clear example if needed. Okay. So let's take a look at this first example. This is pretty straightforward because it's using our conversion factor. 1 inch is equal to 2.54 centimeters. And we don't have to do multiple steps. So this is a pretty straightforward example. So it says your European hairdresser, because you know we all have one of those, wants to cut your hair 8 centimeters shorter. Well, I'm not European, so I don't think in centimeters, even though I use metric measurements all the time, especially in teaching. I don't readily know right off the top of my head how many inches is 8 centimeters. So I have to do a conversion, all right? So the question is, if Fabio wants to cut 8 centimeters off of your hair, how many inches is that going to be? All right. So you have to look at this example and say clearly, what unit am I starting off with and what unit do I want to go to? And you see that written in yellow here, right? Centimeters is what you're starting with. Inches is what you want to end up with. All right. So the 8 centimeters is the measurement that you're starting with. And I like this technique because I write that measurement out front. Notice there's nothing underneath it. That's what I'm starting with. Okay. And then I line up my conversion factor with the inches on the top and the centimeters on the bottom. So 1 inch on top, 2.54 centimeters on the bottom. Those two things are equivalent. They equal 1. So I'm not changing the value. I'm just expressing the measurement in an equivalent unit. Okay. So when I line up my conversion factor with the inches on top and the centimeters on the bottom, my centimeters cancel out because those are like units. I'll multiply 8 times 1 and then divide by 2.54. I get 3.15 as my number and inches as my unit because that's what's left when I do it after I cancel. Okay. Now, again, let me just stress this. This is my way of doing things. You don't have to do it my way. Whatever way you choose, you have to show me. Okay. Any questions on this first example?
No, ma'am.
Thank you. All right, so let me scroll down a little bit. Let's take a look at another example. Now this one's a little bit more involved, okay? Because you have to do it in a multi-step fashion. It says, how many milliliters are in 1 quart of milk? Okay, so you have this quart of milk, all right? And you want to know how many milliliters can I put in there, right? Okay, and so in this particular example, again, step 1, what unit do you have? Quarts in this case. What unit do you want to end up with? Milliliters, okay? So I know my measurement that I'm starting with is 1 quart. The question is, what conversion factor or factors will help me to get to milliliters? Okay, so if I go look on my handy dandy conversion chart, one of the things I find is 1 liter is equivalent to 1.057 quarts. So 1 liter divided by 1.057 quarts is 1 because they're equal. But I can use that to get rid of my quarts and convert to liters. Okay. Now you might be asking the question, well, why didn't it just go right straight from quarts to milliliters? That's what the question asked, because on my handy dandy conversion chart, I don't have a conversion factor that goes straight from quarts to milliliters. I have a conversion that goes from quarts to liters. And that is because that is a logical conversion. Most any conversion chart that you look at that has volume units will have a conversion factor that'll take you from quarts to liters or liters to quarts, right? So 1 liter is equivalent to 1.057 quarts. If I line up the conversion factor so that the quarts are in the denominator on the bottom, quarts will cancel out. And I'll be left with liters. Now, here's the thing. The question didn't ask me for liters. The question asked me for milliliters. So I have to take this a step further. I need a conversion factor that will take me from liters to milliliters. And there are 1,000 milliliters in 1 liter. That's a conversion factor. 1,000 milliliters is equal to 1 liter, okay? So if I line up that conversion factor, the liters will cancel out. And then I no longer have quarts. I no longer have liters. All I'm left with are milliliters. So I multiply my top numbers, 1 times 1 times 1,000. I multiply my bottom numbers, 1.057 times 1, and then I divide, okay? And I'll follow that process faithfully because while there are ones in the numerator and ones in the denominator, sometimes that isn't the case. And so if you follow the process, multiply your top numbers, multiply your bottom numbers, then divide, you avoid the possibility of, you limit your chances of making a mistake, okay? So when you do that math, you get 946 milliliters. So if you had a quart of milk, it would be equivalent to 946 milliliters of milk, all right? Now, you might be thinking, I wouldn't have done that all in one. I would have converted the quarts to liters in the first step and then converted the liters to milliliters in the second step. I would have broken it down in 2 steps instead of writing it all in one. Perfectly fine. As long as when you finish, you have successfully converted quarts to milliliters, you can do it however you like, as long as you show me, okay? Any questions about this example? Man, I must be batting 1,000 because y'all are quiet. All right. Let's look at another example. And by the way, these examples are really great if you want to have an example problem with the conversion factor shown. If you need it, for example, in this one, you need a conversion factor that goes between kilograms and pounds. There you go, right here in this example. If you printed out this example and had it available while you're doing your assignments or your exam, you'd be fine. Okay. So my examples have conversion factors built in that you are free to use, okay? All right, so let's look at this example. It says, assume your mass is 55 kilograms. And again, I don't readily think in kilograms because in this country, if somebody asks you your weight, you give pounds, right? So the question is, if your mass is 55 kilograms, how many pounds do you weigh? All right. So again, what unit am I starting with in this case? Kilograms. What unit do I want to end up with when I finish? Pounds, okay? So I have a clear mapping of where I start and where I want to finish. The measurement is 55 kilograms. So notice it's written out front. There's nothing underneath it. That lets me know that's the measurement that I'm starting with. And then I line up my conversion factor. Well, 2.2 pounds is equivalent to 1 kilogram. If you look on a conversion chart, you'll find that 2.2 pounds equals 1 kilogram. Now, honestly, we have to look at this and say, okay, kilograms is technically mass and pounds is technically weight. They're not the same property, right? And I just told you earlier, you can only convert if they're the same property. So why is it that I can convert mass to weight? Because on this planet, gravity is approximately, on average, 32 feet per second squared or 9.8 meters per second squared. Fairly constant. So there's a mass weight equivalence because gravity is constant, okay? So that's why we can do 2.2 pounds per kilogram. But technically, these aren't the same property, okay? So, but I have a conversion factor that I can use to convert. from mass to weight in this instance. So if I line up my conversion factor with the kilograms on the bottom and the pounds on the top, my kilograms cancel out. Multiply my top numbers, 55 times 2.2, and divide by 1. I get 121 pounds. So if you had a special scale that measured mass, and your mass was 55 kilograms, you would know that the equivalent is 121 pounds. And this is an important kind of conversion. I don't know if any of you have children, but I've had younger, when my kids were younger, and I got grandbaby now. And when you go to the doctor, a lot of times to know what medication to give, they have to use a chart equivalence to tell them, okay, if the baby is this many pounds, it's equivalent to this many kilograms, this is how much medication you have to give. That is because most companies that manufacture medicine, the medicine is distributed using metric units. And so that's why the doctors have to know a weight to mass equivalent to know how much of a dosage to give. So there's a practical reason for needing to know that, okay? Any questions on this example? All right. Let's look at another one. So it says, how many feet long is a 5K? That K in this case is not a temperature. I had a student say Kelvin. No, this K stands for kilometers. That's just jargon, right? We have to know the difference between everyday language and an actual measurement. This K is referring to kilometers. So they're asking you, how long is a 5-kilometer race, not a 5 Kelvin race? That wouldn't make any sense because Kelvin is temperature, right? So how long is a 5-kilometer race? They want to know how many feet. If you ran 5 kilometers, what would be the equivalent in feet? So in this example, I'm starting with kilometers. Some people say kilometers, 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 right? I'm starting off with kilometers and I want to end up with feet. So I have to have a clear visual in this case because I've got to do this in a multi-step process. And so, you have to be careful. I've actually seen students do that. They convert kilometers to miles and then miles back to kilometers, and they never get to the feet because they keep going in circles, right? So you have to keep, in your mind, what conversion are you actually trying to make, okay? So in this particular example, I'm starting off with the measurement of 5 kilometers. That's why it's written out front. I know that's the measurement I'm starting with. And then I can go about the business of doing the conversions to get to the unit and measurement that I want, okay? So if I look on my handy dandy conversion chart, one conversion that I find is 1 mile is equal to 1.609 kilometers. And that is because that is a logical conversion because a mile and a kilometer are fairly close in size. And so I just have to take that conversion factor and line it up properly to cancel out my kilometers. Now, you just have to be mindful that the question did not ask you for miles. They asked you for feet. So you have to take this step further. You now need a conversion that'll go from miles to feet. Well, fortunately, on my handy dandy conversion chart, it says 5,280 feet is equal to 1 mile. Okay. So I lined up my conversion factor so that I cancel out my miles and keep the feet. So I did this in a multi-step process. First, I converted my kilometers to miles, and then I converted my miles to feet. Okay. Now you don't have to write it out all in one like this, or again, you don't even have to use my technique. Whatever technique you like, sure, use that. Show me. Okay. So when I do the math here, I multiply 5 times 5,280 and then I divide that by 1.609. That gives me 16,408 feet. Okay, so if you ran 5 kilometers, that would be equivalent to 16,408 feet. Okay, so let me see who's got their thinking cap on out there right now. We figured out how many feet in this 5 kilometer race. My question to you is, how many miles is that? How many miles is 5 kilometers, or how many miles is 16,408 feet? Somebody want to take a stab at it who's actually working this along with me?
Isn't it 2.2 kilometers?
Well, the question started off with kilometers. My question
I mean,
to you is,
you asking for how many miles?
miles. So how did you do that?
I don't really know. I'm just kind of taking a shot at it.
Oh, okay. So again, you have to follow the process, right? You have to be true to the process. If I were going to take my 5 kilometers and convert it to miles, I would only have to do the first step. I would I would divide the 5 kilometers by 1.609 to get my miles. And then you'll get something like 3.11, somewhere in that neighborhood.
Okay.
Yes, it's 3.11.
Right. So you have to take the 5 kilometers and use the first conversion factor, 1 mile divided by 1.609. Your kilometers cancel. And after the first step, you will have miles. The only reason I had to take the second step and convert the miles to feet was because the question asked me for feet, right? But if the question had asked me for miles, after the first step, I'd be done. And I get 3.11. So if, see, I didn't see a name pop up of who responded first with the answer, but I appreciate you responding, because you see, as I said earlier, I always tell students, yeah, it looks easy when I do it because I've been doing this for a long time. The question is, do you understand what I'm doing? Can you replicate that and give me the correct answer? And it always looks like, oh, yeah, I got this. But the devil is in the details. When you actually have to do it, you see, that's where we run into, oh yeah, well, see, I'm not really sure, right? But I don't want you walking away from here saying, I'm not really sure. If I move the screen off example number 6 and you're not really sure, you need to be asking questions, okay? So see, we can't skate over these things because they will come back to bite you. You have to ask your question. I'm not sure how you did that. I'm not sure why you did that. Please, what questions do you have before I move forward?
When I worked out the problem, I got a decimal. So I'm just wondering if you still want us to round to the second decimal, or do you want us to round up?
No, the 2 decimal places would have been fine, right? I would have had no issue. If you did all the math and then in the end you got 2 decimal places and that's what you kept, fine. You know what I'm going to look at more than anything? What process did you follow? Did you set it up correctly? Is the work that you showed correct? With the work that you showed, do I get the answer, right? That's within reason, right? That's what I'm looking for. Whether you rounded it up to 16,408 feet or you kept 2 decimal places, if you can't set it up correctly, it doesn't matter because you're not going to get anything that makes sense, right?
Okay, thank you.
Yeah. Thank you, Tiffany. I really appreciate your interaction this morning. That you'd be surprised, but the questions you're asking, probably more than half of the class has the same question, but they aren't asking, and they aren't interacting and being as brave as you. So I really appreciate it. Okay. Anybody else, please ask.
For the step you have right here, and it goes from 5 kilometers and then to the right, the bottom right of that in the graph.
on the graph?
That's how many kilometers are in 1 mile?
Yes, 1 mile is equivalent to 1.609 kilometers. That's a conversion factor. Remember, a conversion factor is a fancy way of writing one, because if 1 mile and 1.609 kilometers are equal to each other, when I divide by them, I'm in essence, I have one, right?
Yeah, yeah.
And you get those conversion factors from conversion charts. So it's not something that I just pulled out the sky. It's an actual equivalence that comes from a conversion chart.
So how'd you end up, did you multiply 1.609 to 5280?
No, because the 5280 and 1.609 are on like in a fraction, right? So you divide, right?
Okay.
So I have to multiply 5 times 5280 and then divide by 1.609. Yeah.
Okay. All right.
Good question. Thank you very much. Anybody else, please ask.
Could we set it up and put it like 1 mile equals 5K over 1.609 to get that answer?
Wait, say it again. I didn't say it slowly for me.
The way that this picture is set up is a little confusing. When I usually do the conversions, I usually do like the main conversions of like 1 mile equals 5 kilometers. And then I put that over
1 mile is not equal. 1 mile is not equal to 5 kilometers.
Okay, because when I did 5 over 1.609 and then times it by the 5280, I got the 6.
That's
I got
correct.
a decimal. Okay.
That's if you multiply 5, if you did it this way, you did it the first step in 2 steps. You took the 5 divided by 1.609, and that'll give you a number, right?
Yes.
And that number will be the number of miles that you have. And then you take that number and multiply it times 5280, and that'll give you the number of feet that you have.
Yeah.
But what I'm doing is I'm setting it up to show you the units canceling out. You're not necessarily showing me the units canceling out. You're showing me how the numbers work.
Okay.
Which is fine as long as you show me what you multiplied by.
Okay. Thanks.
That makes sense to you?
Yeah.
Okay.
Okay.
Yeah, I mean, I get it. You know, there are different ways that people approach these problems. I have to work it out where I don't assume anything. I have to show all of the work involved, right? Whereas you might be, you know, if you look up the conversion fact, oh, I just need to divide by 1.609 and then multiply times 5280. Cool. Any other questions?
I don't know if this is too much to ask, but is there any way you can give us a few example problems that we can work out real quick?
That's what these are. So that's exactly what you were supposed to do for me, right? Remember I told you to go and find some examples of a unit of conversions, or make up your own, work it out, and then bring it here, and we were going to share it. And then I mentioned I would have given you bonus points for doing that. But since nobody did it, I don't have any other examples other than my own. So that's why I'm going through my examples. But you were supposed to bring me some examples that aren't in the notes. So, I mean, I guess I'm asking a question other than the ones that are in my notes. Do any of you have an example that you want me to work? Okay, so here's what we can do. Since y'all are all here and you missed the opportunity today to get the bonus points by bringing in an example that you want worked out or that you worked out, on Tuesday, before we move into the next topic, I'm going to take about 10 minutes and we'll do a couple of examples that aren't in these notes and aren't in the notes that I covered on Tuesday. I'm not giving any bonus points. because you missed that. But at least I will try to do 2 problems that aren't in these notes, and we'll set them up from scratch and work them out, okay?
Yes, ma'am.
Okay, because you don't have a problem set on this due Saturday. The problem set that you have due Saturday is on last week's work. So we'll work a couple more examples that deal with unit conversions before you have to turn in problem set number 2 next Saturday, okay?
Okay.
All right, so now I hope that you're comprehending the method to my madness in having you go and find an example, attempt to work it out, and bring it back to share. Because when I'm doing it my way, and it, you know, you might be, well, I see what she did here, but then when you have to go do it on your own, it's different. So that was why I was trying to force the issue of you bringing in some samples. But again, now I think you understand why, and I'm sure I'll be having lots of examples on Tuesday. And I did tell you guys on Tuesday that even if I didn't cover your example, if you send it to me, I will work it out and post all of those in the announcement with the video. So I will still do that. It'll just have to be for Tuesday. Okay. All right. So let's take a look at a couple more examples. I think I got 2 more in this, all right? And remember, you have access to this, so you can come back and look at these examples at any point. And what I always tell students, when you come back and review the notes, because remember, reviewing the notes, and in this case, the videos are the notes, you're supposed to do that for this class, right? If you aren't going back and reviewing this stuff, then it makes it more difficult for it to stick, all right? So it says here, how many grams does a 10-pound bag of potatoes weigh? Okay. So now, if you've ever gone in the grocery store, in the produce section, you've probably seen a 10-pound bag of potatoes. What this question is asking is how many grams is that? Okay. So we're starting out with a measurement of 10 pounds. And what I need to do is convert that until I end up with the equivalent in grams. So I do have a conversion factor. 1 kilogram is 2.2 pounds. In fact, I used that same conversion factor earlier, except in that example, I used it to convert kilograms to pounds. In this example, I'm using that conversion factor to convert pounds to kilograms, all right? So I have to line it up properly. To line it up with the kilograms on top and the pounds on the bottom. 1 kilogram is equal to 2.2 pounds. So if I line them up one on top of the other, it's 1. I haven't changed the value. I've just changed the unit that it's expressed in. So 1 kilogram divided by 2.2 pounds, my pounds cancel out. And now I have kilograms. So let me see if you got your thinking cap on. Tell me how many kilograms is 10 pounds?
$4.5.
4.5, because you took 10 and divided by 2.2. Am I correct?
Yes, ma'am.
All right. So if you had stopped after the first step, you would have 4.5 kilograms. But here's the thing. They didn't ask me for kilograms. They asked me for grams, right? So what I have to do is I have to take this another step. So now I have 4.5 kilograms, and I need to convert that to grams. So I have to take my 4.5 kilograms and multiply it by 1,000 grams for every 1 kilogram. That way I can cancel out my kilograms and keep the grams. Now, they carried it out more decimal places than 4.5, but if you didn't go as far with the decimal place on the first step as they did, then that's fine. I'm looking for, did you approach the problem correctly, and is your answer reasonable for what you did, okay? So I take that and multiply by 1,000, and in this case, I get 4,545 grams, okay? So what the young lady who responded, if you did 4.5 as your first, in the first step, you would have got like 4,500. Make sense?
Yes, ma'am.
Okay. So again, you have to always be mindful of what are they asking you to find? What conversion factors do I have available? How can I use them to get to the answer that I want? Okay. Any questions on this example?
No, ma'am.
Okay, let's do one final example together. Then we'll have a few minutes left for questions, and then we'll call it a day, right? So Taft football needs 550 centimeters for a first down. How many yards is this? So I don't know what they're doing at Taft, but whatever game they're playing, they're measuring in centimeters. So maybe it's rugby or something. I have no idea. But they need 550 centimeters to get a first down. Now in this country, we don't do centimeters. We do yards. When we play football in the United States, it's yards, right? So, Mahomes needs 550 centimeters to get a first down, and oh well, you know how that went. All right. So our measurement is 550 centimeters. We got to convert that to yards. So now I got to look on my handy dandy conversion chart and see what conversion factors do I have available. One that I definitely have available is 1 inch equals 2.54 centimeters. So I have to line them up so that the centimeters cancels out. Okay. But they didn't ask me for inches in this case, because after the first step, I'll have inches because my centimeters are gone. I canceled them out. Okay. So I got to keep working because they didn't ask me for inches. Oh, but wait, I have a conversion factor. 1 foot is 12 inches, or as we say, 12 inches in a foot, right? But I have to line that up so I cancel out the inches. Okay. So after the second step, I have feet. But again, they didn't ask me for feet. They asked me for yards. So on my handy dandy conversion chart, 3 feet is equal to a yard. So I have to line that up so that I cancel out the feet. And then finally, the only unit I have left after the third step is yards. My centimeters canceled out, my inches canceled out, my feet canceled out. I'm left with yards. In this instance, pay attention here because this is where students get into trouble. I have 550 as the number on the top, but I have to be careful. I need to multiply 2.54 times 12 times 3, and then take 550 and divide by that number. See, this is an example where you don't have 1 on the bottom. Okay. And what some students mess up doing, they take 550 divided by 2.54, and then they multiply that by 12, and then they multiply that by 3, and totally botch that. Okay. That's why my directions to you were multiply all your top numbers, multiply all your bottom numbers, and then divide. Take that extra step to avoid making a mistake. Okay. So if you do all that correctly, you get 6.01 yards. Now, we might say 3rd and 6. We don't say 3rd and 6.01, but you get the idea, right? 2 decimal places, that's fine. Or if you rounded it off and said 6, that would be fine. What I'm looking at is your process correct? Okay.
So would 6.05 be correct?
That's fine if your process is correct.
Okay, just making sure. Thank you.
Yeah. I don't look. We could spend all day trying to figure out, is it 01, 05? But if you didn't set it up correctly, you aren't going to get either of those, right? So that's why I need you to show me your work, because I can tell from your work whether the math is going to turn out right. Within reason, right? I mean, if you got 8 yards, then I'll be like, you did something wrong there. Okay. Make sense to everybody?
Yes, ma'am.
Okay, we got about 5 minutes left. I want to know, what are your questions? All right, so if you're working on this material or anything else over the weekend and you have questions, please don't hesitate to reach out to me. You can email me, I'll respond back to you. And we'll try to, address any questions you have. I am going to post a video for today's session as soon as I can get it captioned. And I will go back and review the link on Google to see, like, do I need to adjust the link so that everybody has permissions for it? And then on Tuesday, we'll do a quick check to let me know. If you want to, once I fix the link, I'll post it in an announcement saying I've updated the link, and then you can try it. And if it gives you grief, please email me right away. Otherwise, the first chance we'll have to diagnose the issue is on Tuesday. And then I'll have to figure out some other technique for you to have access if that doesn't work. Okay. Any questions?
No,
All right.
I'm good.
All right, thank you. So with that, I'm going to stop the share. And I will stop the recording.